In order to confidently multiply algebraic fractions, we need to be able to solve quadratic equations, both where our coefficient of x squared is 1, as well as when our coefficient of x squared is greater than 1. We also need to be able to factorize equations which have a difference of 2 squares. We need to know how to multiply ordinary fractions. So if you do not know how to do any of these topics, or if you feel you need a recap on these, then I will put a link in the description box. So please do check them out before you proceed with this video. When we are multiplying algebraic fractions, we just want to multiply them like normal fractions, where we multiply the numerators with one another and the denominators with one another. So in number 1, we've got 3x over 4 times 2 over 5x. So we can first multiply the numerators, which are 3x and 2, and the denominators, which are 4 and 5x. This gives us 6x over 20x. We can then check to see if we've got any common factors so that we can simplify our answer. So as we can see, we've got x in both the denominator and numerator, so we could cancel those out. We've now got 6 over 20 left, and the highest common factor of 6 and 20 is 2. So we can do 6 divided by 2, which gives us 3, and 20 divided by 2, which gives us 10. This cannot be simplified anymore, so this is our final answer in its simplest form. For number 2, we are also going to multiply the numerators by each other, which are x plus 2 and x minus 3. And we are going to multiply the denominators by each other, which are x minus 3 and x plus 5. We can then see that x minus 3 is a common factor in the numerator and denominator, so we could cancel those out with each other, which leaves us with x plus 2 over x plus 5 as our final answer. In number 3, we've got x squared minus 9 over 4x times 2x over x plus 3. As we can see, the numerator x squared minus 9 is a difference of 2 squares. Whenever we see any expression that can be factorized, we should first factorize it before we multiply. So x squared minus 9 can be factorized as x plus 3 and x minus 3. We are then multiplying it with the other numerator, which is 2x, and the denominators are 4x and x plus 3. As we can see, we've got x plus 3, so we could cancel those out with one another. We've then got x in both the denominators, so we could cancel those out. And then we've got 2 and 4, and the highest common factor of 2 and 4 is 2. So we can divide 2 by 2, which gives us 1, and 4 divided by 2 gives us 2. We are then left in the numerator with x minus 3, and in the denominator 2. And that is our final answer for number 3 in its simplest form. So for number 1, in the first numerator, we've got x squared minus x minus 6, which is a quadratic equation. So if you're not confident with quadratic equations, I will put a link in the description box. In order to factorize a quadratic equation, we are first going to look for two numbers that multiply to give us minus 6, and the same two numbers need to add to give us minus 1. And the two numbers we will be using are minus 3 and 2. So we can factorize this first numerator as x plus 2 and x minus 3. We are then multiplying it with the x plus 4, which is the second numerator. And in the first denominator, we've got x squared minus 16, which is a difference of 2 squares. So we can factorize that as x plus 4 and x minus 4. We then multiply that with the second denominator, which is x minus 2. As we can see, we've got some common factors here, like x plus 4 and x plus 4. So we can cancel those out, which leaves us with x plus 2 and x minus 3 in the numerator, and x minus 4 and x minus 2 the denominator. And that is our final answer for number 1. For number 2, we've got x squared minus 5x plus 6 in the numerator, which is again a quadratic equation. So here, to factorize that, we are going to look for two numbers that multiply to give us 6 and add to give us minus 5. The two numbers we will be using are minus 2 and minus 3, which means we can factorize this as x minus 2 and x minus 3 We then multiply it with the second numerator, which is x plus 3. And in the denominator, we've got x squared minus 9, which is the difference of two squares. So we can factorize that as x plus 3, x minus 3. And we multiply it with the second denominator, which is x minus 2. So here we've got lots of common terms that we can cancel out with each other in the numerator and denominator. First, we've got x minus 2. We've also got x plus 3. And we've also got x minus 3. Because all the denominators cancel out with all the numerators, this means that this is just one whole. So our final answer is just one whole for number 2. Here we've got a few practice questions, so please feel free to pause the video and have a go independently. Here we also need to work out the algebraic fractions and give the answers in their simplest form. So for number 1, in the numerator we've got x squared plus 3x. And we can factorize that by factoring out the common term in x squared and 3x, which is x. In order to make x into x squared, we would have to multiply it by x. And in order to make x into 3x, we would have to multiply it by 3. We then multiply it with the second numerator, which is x. And that is all our numerators multiplied. For the denominator, we have x squared minus x minus 12, which is a quadratic equation. So in order to factorize that, we need to look for two numbers that multiply to give us minus 12, and they should add to give us minus 1. So the two numbers that we will use are 3 and negative 4. We can therefore factorize that as x plus 3 and x minus 4. We can multiply it then with the x minus 4 in the second denominator, which is that denominator. And as we can see, we've got a common term in both the numerator and denominator, which is x plus 3, so we could cancel those out with one another. And this leaves us with x multiplied by x in the numerator, which is x squared. And in the denominator, we've got x minus 4 and x minus 4. Because x minus 4 is being multiplied by itself, we can even write this as x squared over x minus 4 squared. And that is our final answer for number 1. For number 2, we've got x squared minus 9 in the first numerator. And because that's a difference of two squares, we can factorize that as x plus 3 and x minus 3. We then multiply it with the second numerator, which is x minus 3. And in the denominator, we multiply x by x plus 1. As we can see in this one, we've got no common factors in the numerator and denominator, but we've got x minus 3 in the numerator, which is multiplied by itself. So in a simpler way, we can write this as x plus 3 and x minus 3 squared over x multiplied by x plus 1. And that is our final answer for number 2.